students, in this lecture we are going to study some more applications of differentiation like maxima and minima, radius of curvature, circle of curvature, its center, evolutes, involutes and their properties along with the examples. Now, we learn to find maximum and minimum values of functions, and that skill allows us to solve many kinds of problems in which we need to find the largest or smallest value in a real world situation. Our differentiation skills will be applied to graphing and will use differential to approximate function values. In the last lecture, we have learnt that when f dash c is less than 0, we have f of x less than f of c for c in the interval a minus delta less than c less than a plus delta and f of x greater than f of c. That means, we at that time we have seen that we are going to use the concept of function is increasing or decreasing. That is, f dash x greater than 0, the function is increasing, f dash x less than 0, the function is decreasing. Now, we are going to use the same concept to find the maxima and minima of the given function. For that, we first use first derivatives tests to classify maximum and minimum values. If f of a is a relative maximum or a relative minimum value of a function f, then f dash a, if it exists, then it is 0. That means, you have f of a is either maximum value or minimum value, its first derivative exists and it is 0. How you prove this? Suppose f of a be a relative maximum at a, then there exists a delta greater than 0 such that f of x less than or equal to f of a for mod x minus a less than delta. What do you mean by that? You have f of x minus f of a by x minus a less than or equal to 0 for a less than x less than a plus delta. What it is? It is the right hand derivative, that is the limit extends to a plus f of x minus f of a by x minus a is less than or equal to 0. Also, you have when right derivative is less than or equal to 0, then left derivative will be greater than or equal to 0. That means, you have limit extends to a minus f of x minus f of a by x minus a is greater than 0. What do you mean by that? Left limit exists, right limit exists. So, you have f dash a exists, which implies that both the limits are equal and equal to 0. So, similarly, we can prove when f of a has a relative minimum or f of a is a relative minimum, then f dash a, if at all it exists, means it is 0. Students, this is only the necessary condition to have f of x to have relative maximum or relative minimum, but it is not a sufficient condition. Why? Because if you take the function f of x is equal to x cube, then when x greater than 0, f of x is greater than f of 0 and x less than 0, then f of x is less than f of 0. What do you mean by that? F of 0 is neither a maximum nor a minimum, but what is the derivative of x cube? It is 3x square and f dash 0 is 0. So, we can say that the condition or the necessary condition for f of x to have a relative maximum or relative minimum value at f of value f of a at x equal to a is f dash a is 0. Students, let us find minimum or maximum value by using first derivative test. So, here suppose f is a function defined on open interval I. Let f be a continuous function at a critical point c in I. Then, if f dash x changes sign from positive to negative as x increases through c, that is, if f dash x greater than 0 at every point sufficiently close to and to the left of c, and f dash x less than 0 at every point sufficiently close to and to right of c, then c is a point of local maxima. At the same time, we can define local minima also. How you define local minima? In place of f dash x greater than 0, we take f dash x less than 0 at every point sufficiently close to left of C, and f dash x greater than 0 at every point close to right of C. Then C is a point of local minima. So, look at this graph. See here, you take these points C1, C2, C4, C7 and C8. These are all critical values. Why? Because you have f dash C exits. See here, f dash C exits means tangent to the curve exits and they are parallel to x axis. So, and also if you take C3, C5 and C6, these are the critical values because f dash C does not exits for each value. Look at this diagram. See, if f dash x does not change sign as x increases through C, and then C neither a point of local maxima nor a point of local minima. In fact, such a point is called the point of inflection. So, about this we are going to learn in next one. See, look at this one. This figure will give you a clear idea when the function will have relative maximum and relative minimum. See here, at critical value where there is a relative minimum, the function is decreasing on the left of the value and increasing on the right. So, what is the relative maximum? At a critical value where there is a relative maximum, the function is increasing. Function is increasing on the left, decreasing on the right. So, here in this way we can interpret the decreasing and increasing based on decreasing and increasing values of a function when it will have relative minimum or relative maximum. Now, see, look at these examples. Suppose you have a function f of x is equal to x minus 1 whole cube into x plus 1 whole square. So, what we will do, first point we have to do is find dy by dx applying UV rule. Okay? Find dy by dx and equate them to 0. By equating dy by dx to 0, you will have values for x, that is here x is 1 or minus 1 or x is minus 1 by 5. So, first step what we have to do is find the value of dy by dx. Okay. Now, we have to examine whether there are these points are local maximum or local minimum. See here, what is dy by dx? You have x minus 1 whole square into x plus 1 into 5x plus 1. Now, here you have x minus 1 whole square is always positive. Therefore, the sign of dy by dx is the same as this x plus 1 into 5x plus 1. Look at this diagram, the changes in signs of dy by dx for different values of x. See here how it will be from minus infinity to minus 1, minus 1 to minus 1 by 5, 1. So, these are the signs of dy by dx for different values of x. Clearly, you have dy by dx does not change its sign as x passes through 1. So, x is neither a point of local maximum or nor a point of local minimum. Actually, x equal to 1 is a point of inflection. Now, here dy by dx clearly changes the sign positive to negative as x passes through minus 1. See here. So, you have sign from positive to negative as x passes through minus 1. So, you have x equal to minus 1 is a point of local maximum. So, what is the value of this local maximum? It is f of minus 1. We have seen f of a is the relative maximum or relative minimum. So, first you check where the point, at which point dy by dx is changing its sign, negative to positive or positive to negative. Based on that, you decide whether it is maximum point or minimum point. How you find local maxima or minima? By substituting the value in the given function f of x. Now, here, so similarly, if you check for x is equal to minus 1 by 5, we have seen that it is the local minimum value. As usual, we have to substitute minus 1 by 5 in place of x in f of x. Okay. So, if you take any polynomial function, you want to check whether it has a relative maximum or minimum. It is a little bit difficult when where it is changing its sign either positive to negative or negative to positive. So, to avoid this, we can have second derivative test for relative extrema. That means, you can by using second derivative test, we can find maxima and minima of a given function very easily. Now, suppose the function f is differentiable for every x in an open interval a b. That means, your c belongs to open interval a b for which f dash c is 0. How you find maximum value or minimum value using second derivative test? First, we will find f double dash c of f double dash c. That means, first we find the second derivative, in that we substitute the point c. If f double dash c is greater than 0, then f of c is relative minimum, and f double dash c is less than 0, then the function will have maximum value. So, this concept is used to find when the where the function is having, at what point the function is having maximum value or at which point the function is having minimum value, and we can apply to several functions. Now, look at this example. Find all the points of maxima and minima. Whenever a polynomial is given, first find f dash x. If you find f dash x, what is f dash x? First find the derivative, that is 2 x cube minus 21 x square plus 36 x minus 20. So, you may equate f dash x to 0. So, if f dash x equal to 0 means you have 6 x square minus 42 x plus 36 equal to 0, or you have the values of x as 1 and 6. Now, at 1 and 6 you find f dash x. Okay. Find f double dash 1. You have f double dash 1 is less than 0. If f double dash 1 is less than 0 means x equal to 1 is a point of local maximum, and find f of 1, you will get a maximum value. And at the same time find f double dash 6. F double dash 6 is greater than 0 means x equal to 6 is a point of local minimum. So, you have to find the minimum value of f of x, which is f of 6. F of 6, you substitute 6 in place of x, you get the value as minus 128. Observe carefully, always minimum value will be less than the maximum value. Just see where we apply this maxima and minima. Take one problem. See, find two numbers whose sum is 24 and whose product is as large as possible. That means, he is asking when the product of these two numbers will be maximum. Let the numbers be x and y, given that x plus y is 24, x plus y is 24. Suppose p is the product, that means, here p is x y. Clearly, you have p, the product is maximum when x is equal to 12. Why? Because if p is x y, that means x into 24 minus x, which is equal to 24 x minus x square. Find dp by dx, it is 24 minus 2x. What is d square p by dx square? Minus 2. D square p by dx square at x equal to this 12, it is nothing but d square p by dx square is minus 2 at the point x equal to 12. So, the p is maximum when x is equal to 12. So, you have to find where this derivative is negative. And the next one, you see, the three sides of a trapezium are equal, each being 6 inches long. Find the area of the trapezium when it is maximum. All of us know what is the area of the trapezium, half into sum of the non-parallel sides into height. Similarly, you take the area find dA by dx at dA by dx and equate dA by dx to 0 and find the value of alpha, then find d square A by dx square which is less than 0 for alpha is equal to pi by 3. So, you have A is maximum at alpha is equal to pi by 3 and its area we can find by substituting the values. Students, this is about maxima and minima. In the first derivative test, what we have to check is, you have to check for where dy by dx increases or decreases, from which point to which point it is changing its sign, negative to positive or positive to negative. So, that is the first derivative test. In second derivative, no need to check for the changes of signs. You have to calculate f dash x which is equal to 0, find the values of x. From there you get values for x, that is either a, b, c, like that you will get values. So, find d square y by dx square at these points. Then if f double dash x is less than 0, you will have maximum value. If f double dash x greater than 0, you will have minimum value. And the next one more concept of differential calculus is curvature. What is a curvature? Curvature means bending of a curve. The numerical measure of bending of a curve is known as curvature. At a particular point on the curve, a tangent can be drawn. So, this tangent may make an angle psi with the positive direction of x axis. So, the curvature is defined as the magnitude of rate of change of psi. That means, curvature at P is modulus of d psi by ds. Radius of curvature is nothing but reciprocal of curvature. Generally, we denote radius of curvature by rho. So, this is one more important concepts of differential calculus. Now, we will find radius of curvature for given curve y is equal to f of x in Cartesian curve. Suppose y is equal to f of x is a curve, then we will find dy by dx and then d square y by dx square. The formula for radius of curvature is 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. The positive root is taken in the numerator of above formula. Therefore, the radius of curvature is always positive, and when you have d square y by dx square is positive. That means, the curve is concave upwards, and negative if d square y by dx square is negative, that is when the curve is concave downward. So, at the point of inflection your radius of curvature is not defined. So, here suppose when the equation of the above formula is for y is equal to f of x, sometimes there may be curves of the form x is equal to f of y. Then you have rho is equal to 1 plus dx by dy whole square whole power 3 by 2 divided by d square y by d square x by dy square. Just to note down the changes between the little change in the formula. See here, when the curve is of the form y is equal to f of x, you have rho equal to 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. When x is of the form x is equal to f of y, or when the curve is of the form x equal to f of y, then rho is 1 plus dx by dy whole square whole power 3 by 2 divided by d square x by dy square. These problems can be done only when you know the perfectly the points, the methods of differentiation. Then next one, let y is equal to center circle of curvature and evolutes. Let y is equal to f of x be a curve and p be a point on the curve. Let the curve has the curvature at p, k at p. the circle touching the curve y is equal to f of x at p having same curvature k at p and lying on the same side of the tangent at p as the curve lies is called osculating circle or circle of curvature to the curve y is equal to f of x at p. Then the radius of this circle of curvature becomes it is rho. Okay. Now, the center is called the radius of curvature of y is equal to f of x equal to p and it denoted by k. Now, the center of curvature is called the center of curvature. See, look at this diagram. See, this is the circle, this tangent, this is the center of curvature. The coordinates of center of curvature are given by alpha is equal to x minus y 1 into 1 plus y 1 square by y 2 and beta is given by y plus 1 plus y 1 square by y 2. The circle with its center at the center of curvature C and radius equal to rho is called the circle of curvature. So, here for this circle of curvature the radius of curvature is rho only, center is alpha beta. The coordinates of center of curvature are alpha and beta. Now, students, let us find the circle of curvature for the given curve root x plus root y is equal to root a at a by 4 comma a by 4. So, whenever a curve is given, first point you have to find is dy by dx with respect to x and d square y by dx square. Then you have to find these values at the given point a by 4 comma a by 4. So, if you differentiate root x plus root y is equal to root a, you will get 1 by 2 root x plus 1 by root 2 root y into dy by dx is 0 or dy by dx is nothing but y 1 which is minus square root of y by x. By simplification we get. Now, substitute a by 4 for y and x, you will get a by 4 ante it is 1 only. So, you get d square y by dx square which is equal to y 2. Y 2 means you apply u by v rule for square root of y by x, then you will get d square y by dx square at a by 4 comma a by 4 is 4 by a. So, substitute these values in row, that is 1 plus dy by dx whole square power 3 by 2 by d square y by dx square. So, after finding this one, you have to find center of curvature. You got rho value as a by root 2, center of curvature at a by 4 comma a by 4, substitute alpha and beta. After getting the values of alpha and beta, substitute in the equation x minus a whole square, x minus alpha whole square plus y minus beta whole square which is equal to rho square. So, substitute these values. You got alpha is equal to 3a by 4, beta is 3a by 4. Let y is equal to f of x be a curve and p be a point on it. Let C be the center of the circle of curvature of the curve y is equal to f of x at p. So, the locus of C as p varies on the curve y is equal to f of x is called the evolute. What is the evolute? Whatever the center of curvature we have done in the above problem, that is the locus of center of curvature is known as the evolute of the curve, evolute of the curve. The curve itself is called the involute. So, what are the major important properties of evolutes? The involute of a curve is orthogonal to all the tangents of the curve. The evolute of the curve is independent of parameterization of any differentiable function. The evolute of the curve is the envelope of the normal to a given curve. So, these three properties you have to remember. Now, suppose find the evolute of the parabola y square is equal to 4ax. To find evolute of the parabola y square equal to 4ax, I will find center of curvature. So, for this center of curvature, I will find the locus. So, what are the parametric equations of y square equal to 4ax, it is x equal to at square, y is equal to 2at. So, from this we get dx by dt means 2at, dy by dt is 2a. So, you have dy by dx is equal to dy by dt by dx by dt, that is 1 by t. Again find d square y by dx square, it is minus 1 by 2a t cube. So, you find alpha, you know no center of curvature, alpha is x minus y 1 into 1 plus y 1 square by y 2 and beta is y plus 1 plus y 1 square by y 2. So, substituting this value you will get alpha is equal to 2a plus 3a t square, beta is minus 2a t cube. So, the locus of alpha beta is nothing but our required evolute. By substituting for alpha and beta and then simplifying, you get evolute is given by 27 ay square is equal to 4 into x minus 2a whole square. Dear students, in this lesson we have learned about maximum and minimum points. How you find maxima and minima for a given function y is equal to f of x. For summing up, first we have to find dy by dx, that is first derivative. If dy by dx is equal to 0, solve this equation, you get the values for x like a, b, c. Then find d square y by dx square at these points. After finding d square y by dx square at these points, if d square y by dx square is less than 0, then you have the function, or if d square y by dx square is less than 0, then the function will have maximum value. If d square y by dx square is greater than 0, the function will have minimum value. And we have learned several applications of this maxima and minima. And one more important concept of differential calculus is the radius of curvature. What is the radius of curvature? See, radius curvature means bending of a curve. Now, the formula for radius of curvature is given by 1 plus dy by dx whole square to the power of 3 by 2 by d square y by dx square. And how you calculate? First find, see the radius of curvature, look at this diagram. Coordinates of center of curvature are given by alpha is equal to x minus y 1 into 1 plus y 1 square by y 2 and beta is equal to y plus 1 plus y 1 square by y 2. So, you should know how to find dy by dx and d square y by dx square at the given point. After finding, substitute in this point, in this coordinates, so that you will get alpha and beta. So, if you find locus of alpha and beta, which is known as evolute of the curve. In this lesson, we have learnt about evolutes, radius of curvature, chord of curvature and center of curvature. Thank you.